Hello ladies and gentle ladies, welcome back to another Minecraft modding tutorial for Fabric 1.21.1, and in this tutorial we're going to be working again on our fluid tank, and today we are going to be doing the actual GUI rendering for the fluid itself. And yeah, we're just going to get started. So just briefly before we start, I did want to say, I know it's been a long time since I have posted a modding tutorial. They are coming back. If you want to know why, or you know what's happening, etc., I have a channel update video which I have posted, and I will link that in the description of this video. I'm not going to go into that now. We're just going to get started with the tutorial. So for this, there's many different ways in which you can do this. You can manually draw it in here if you want. However, I'm going to create a widget that will basically do a lot of the work for us, such as like tooltip and that kind of thing. So we actually don't need these to-dos, since we're not going to do it like that. We're not going to render it manually. We're instead going to want to override the init method, and this method runs when this screen is initialized. So this is where you add all your buttons, all your text inputs, all your widgets. And in here we're going to add a fluid widget. First, of course, though, we do need a fluid widget. So we're going to come into our screen package, and we're going to create a new package called Widget, and in here we're going to create a new class and call this fluid widget. This class is going to implement drawable, and then it is also going to implement widget. So this widget is drawable, and it's also a widget. So this will just give us access to some of these things that we're going to need inside of here. So drawable has the render method, which we'll need, and widget has kind of some positional things. Okay, so in here we need a private final single fluid storage. So effectively what this will be our fluid tank, which we're going to grab from our block entity in this case, but it could be from anything. It could be from an item, it could be from an entity, wherever you have your fluid stored. And then we're also going to need a private final supplier of a block pos, which is going to be our pos supplier. Now this may seem really weird. Why do we need to get our block position? And the reason is because the way that fluids are rendered, they can be different depending on where they are in the world. So we need to supply it with the position that it's going to be rendered at, and that way it can be rendered correctly. For example, water in a swamp will look different to water in a warm ocean. It's that kind of difference that we need to have this pos supplier for. Then we're going to need a private final int width and a height, of course. So these are final, these are not changeable. You can make them changeable if you want. It just means you have to do a few extra calculations, but we're not going to bother with that. There's no need. And then we're obviously going to need a private int x and y. So these are changeable, and to be honest, it's fine if you make these changeable. It's completely up to you. You can make these final if you want as well, but we're not going to do that because there is a set x and set y method that we need to override, and we'll do that now actually. So what we're going to do is we're going to hover over fluid widget, and we're going to go implement methods, and we're going to want to implement all of these ones that it has given us to implement. So I'm going to press OK. We'll go over render in a minute, but for now we're just going to fill out these ones. So we're going to say this.x is equal x, and this.y is equal y, and then we're going to return this.x in getx. We're going to return this.y in gety. We're going to return this.width in getWidth. We're going to return this.height in getHeight, and then in for each child, we're actually not going to do anything with this one. We're just going to completely ignore this one for now, probably for the future as well. There isn't much need, since we don't necessarily want a fluid widget to have children. So in terms of doing for each child, we just don't really care about the implementation of that, so we're just going to leave it how it is. Then we are going to want a constructor which is going to help to pass in some of this data. So this is going to be a pretty big constructor. We're going to pass in quite a few things. So we're going to go public fluid widget, and this will take in a single fluid storage, which will be our fluid tank. Then it is going to take in an int x, an int y, an int width, an int height, a supplier of block pos, which is our pos supplier. So those are all of the arguments that we're going to pass in, and then we obviously just need to go and set those in here. So this.fluidTank is equal fluidtank, this.x is equal x, this.y is equal y, this.width is equal width, this.height is equal height, and then this.pos supplier is equal to pos supplier. Okay, so that is all of the things we need. Next, we can go ahead and actually render our fluid. Now, if you watched the previous fluid rendering video on rendering it in the world, this will probably look quite similar, or familiar, I should say. It's going to be very similar to that. So first, we need to go ahead and actually get the fluid from our fluid storage. So we're going to say this.fluidtank.variant .get fluid, which will go ahead and get us the fluid. Then we need to get the fluid amount, so I'm going to say long fluid amount is equal this.fluidtank.get amount. Then we're also going to want the capacity, so long fluid capacity is equal this.fluidtank.get capacity. Then we're going to want to calculate the height of the actual fluid inside of the fluid bar. So I'm going to say int fluid height is going to be equal, and we're going to do the fluid amount over the fluid capacity. And then what we're going to do with that is we're going to multiply that by this.height, which will basically just get us a number in the right range. Now, since this will obviously give us a float, and we actually do need to cast this to a float as well, we then need to do math.round, and if we just pass these in like that, and that then gets us it as an integer. Next, we can go ahead and get the fluid render handler. So this will be the fluid render handler is equal to the fluid render handler registry.instance.get, and we pass in the fluid. Nice and simple, nothing complicated there. Then we just want to check if the fluid render handler is equal null. Then we're going to return, and we're also actually going to add an if statement up here after we've grabbed the fluid amount, which I'm actually going to put at the very top, even though that's going to be a bit confusing. And that's because we just want to say if fluid amount is less than or equal to 0, then what we're going to do is we're going to return, because we don't care about trying to do anything else if there's no fluid in this fluid tank. Next, we need to go ahead and get the block pos. So block pos is equal this dot pos supplier dot get. Then we're going to get the fluid state, so we'll say fluid state is equal to fluid dot get default state, and then we're going to grab the world, so we'll say world is equal Minecraft client dot get instance dot world. One thing that it might be useful to do is say here that if world is equal null, then we're going to return again. Then the next thing we can do is go ahead and grab the sprite. So obviously, if you don't know, fluids have 3 sprites, or at least usually have 3 sprites. They might only have 2. That will be the still sprite, the flowing sprite, and then optionally they will have an overlay sprite. Now what we're going to get here is the still sprite. Obviously, if you wanted the flowing one for whatever reason, you can use that. If you wanted the overlay one, you can use that. I just want to use the still sprite, so I'm going to say sprite is equal to the fluid render handler dot get fluid sprites. This is going to pass in the world, then it's going to pass in the pos, and then it's going to pass in the fluid state, and we're just going to get the first element of this array. Since this is an array of the sprites where the first one is the still, the second one is the flowing, and then the third one is going to be the overlay. You can actually see that right here. Next, we're going to want the tint color, just in case it needs tinting. For example, water will need tinting, otherwise it will be gray. So we're going to say tint color is equal the fluid render handler dot get fluid color world pos fluid state, like that. Now what we need to go ahead and do after this is go ahead and extract the 3 components out of this tint color. So we're going to need the red, the green, and the blue. So to do that, we can do float red is equal tint color. We need to shift it right by 16, and then do and 0xff, and then divide this number by 255. Then we need to do the exact same thing for the green and the blue. The only difference here is that the green we will shift by 8, and the blue we will not shift at all, so that will just be tint color and 0xff divided by 255. After we have all of this information, we can go ahead and render the fluid. Now, in order to do this, we are going to call a method from a class that we're about to create from a util class. So we're going to go into our main client package here, and we're going to create a new package called util. And then inside of here, I'm going to create a new class and call this screen utils. Inside of this class, we're going to create a method which will draw us a tiled sprite. Since we want our sprite to tile, we don't want it to stretch. So we're going to create a public static void render tiled sprite. This will take in a draw context, which will be the context. Then it will take in the sprite we want to draw, which we will call sprite. Then it will take in an int x, an int y, an int width, and an int height. And also an int color, of course, since we have a tint color we need to draw it with. Now, inside of here, there's a few variables we're going to want to set up. So the first one is just going to be the width and height of the sprite. So for this, I'm just going to say int sprite width is equal 16, int sprite height is equal 16. Now, ideally, this is information we would actually get from the sprite. However, I don't believe we can get this from the sprite, or at least I could never find a way to retrieve this from the sprite. In fact, I was incorrect. You can do that by using the sprite contents. I don't know how I didn't find that before, but here you go. So now we can just go ahead and do this then, so we can get height. The next thing we want to go ahead and do is get the x count and the y count. So this is effectively how many of these sprites are we going to tile horizontally and then vertically. Luckily, this is pretty easy to calculate, so we can do int x count is equal mathhelper.floor. The reason we're using mathhelper.floor instead of math.floor is because mathhelper.floor will turn this into an integer for us, so we don't have to do any nasty casting. And in here we just want to do float, so we want to cast our width that we have passed in to a float, and then we want to divide that by the sprite width, and then we want to do the exact same thing for the y count, except obviously with the two heights. Okay, the next thing we need to do is calculate the remainders, because obviously this number may not perfectly go into this number here. So we need to calculate what the remainder will be so that we can draw that afterwards. So we're going to do int x remainder is equal width modulus sprite width. And it's the exact same for the y remainder as well. So that would be height modulus sprite height. The next thing we need to go ahead and do is we need to get the ID of the atlas that this sprite is contained in, since when we're actually going to draw the quad here, we need to use the atlas ID, and then we need to use UVs to determine which actual sprite we want. So what we can do is we can do identifier atlas ID is equal sprite.get atlas ID. Then we have a float min u, which is going to be sprite.getMinU, and then we have a float min_v, which is going to be sprite.getMinV. Then we can start our loop. So we're going to want two loops, of course. So for simplicity's sake, we will go over the x first. So we're going to say for I is equal 0, I is less than x count, I++, and then we're going to go for I again, which is going to be j is equal 0, j is less than y count, j++. We're first going to calculate the x1, so this will be the start, so basically the top left. So this will be equal to x plus I times the sprite width, and we can put these two in brackets if we want, but we know obviously they happen first because of the multiplication anyways, but sometimes it's just easier to read it when there's brackets. So we know that this is going to be basically the index horizontally multiplied by the width, and then we're adding that to the x position that we want to draw it at, which will get us the starting x position of our quad. Then we're going to want the y1, so y1, and this will be obviously exactly the same, so plus j times the sprite height. Then we want the x2, so x2 is equal to x1 plus the sprite width. Nice and simple. For the y2, once again exactly the same, so y1 plus the sprite height. The next thing we need to go ahead and find out is the max u and the max v. Now these are things that we can actually go ahead and put up here as well. So we can do float max u is equals sprite dot get max u, and then float max v is equals sprite dot get max v. Then all we need to do is do context draw textured quad. We're going to pass in the atlas ID, the x1, the x2, the y1, the y2, the min u, the max u, the min v, the max v, and then the color. Now after we have done our while loop here, we need to go ahead and draw the y remainders as well, since we're on our x loop, so it's easier to just do it here. So we need to say if y remainder is greater than 0, then we can say int x1 is equal x plus I times sprite width, and then we can say int y1 is equal y plus the y count times sprite height. Then we want the x2 and the y2, so int x2 is equal to x1 plus sprite width, and then int y2 is going to be equal to the y1 plus the y remainder, since we want to only draw the remaining amount. Now actually, on second thoughts, we're actually going to put the max u and the max v in our for loop here, and the reason is because we're going to have a different max u and a max v for this in here. So we're going to say float max u will be equal to the sprite dot get max u. Nice and simple. The max v though will be a little bit more complicated, so it'll be the min v, since we want to start at that minimum v position on the uv, and then we want to add the sprite dot get max v minus the sprite dot get min v, so effectively getting us the height of that v, and then we need to multiply this by a float, which will be the y remainder, so we cast that to a float, divided by the sprite height. And what that will do is that will basically get us the percentage of how much the remainder is over the actual height of the sprite. And by timesing it by the max u minus the min v, we get the height of the v that we actually want, getting us the max v. So then we can just go ahead and draw it. So it's going to be exactly the same as this. In fact, we can probably just go ahead and copy that in. Okay, now after this for loop for the x, we need to go ahead and do exactly the same as this, but for the x, and then also the y again as well to fill it in that bottom right position. So we're going to have a very similar if statement. So we're going to say if the x remainder is greater than 0, then we're going to do another for loop, which is going to be for the y position. So I'm just going to use j so that we have some consistency here, because we used j for the y's up here. Then I will basically do this exact thing right here. So I'm just going to copy that in, and we'll obviously need to change a few things. So the x will be plus the x count times the sprite width, j times the sprite height, that's fine. X1, this will be plus the sprite remainder, so that is the x remainder, like that. Then we have the y2, which is perfectly fine, that's unchanged. Now the max u will need to be different, so it's going to be the exact same calculation we're doing up here, but with the u and the x and the width instead of these. So what we can do is just min u plus the sprite dot get max u minus the sprite dot get min u, the min u of which we can actually reference from up here, and actually we can do the same with the v as well, so we can use here min v. That will just save us a tiny amount of computation, which would be nice to have. So here we can just change this to min u, and then just multiply this by a float, which will be the x remainder over the sprite width. There we go. And the max v will be exactly the same, so that is unchanged. Then what we want is basically the same thing again, except for the y remainder. So we're going to copy this y remainder from up here, paste it after this loop. We're going to need to change everything to what's in here for the x one, and then for the max u, we're just going to copy that and use that there. And also we need to make sure we change the x2 as well to use the remainder, otherwise that's not going to work either. Now in theory this is all correct, so what we can go ahead and do is not continue, because you will see that we have an error, and that is that draw textured quad cannot be accessed from outside the package, and that is because it is package private. If you go into the code, you can see here that it's package private, so we need to go ahead and make this public. Alternatively, you can copy the method and try and get that to work, but I think it's easier to just make it public. So there's multiple different ways to do this. You could use reflection, you could use mix-ins. However, we are just going to use an access widener. Just for simplicity's sake, we could use a mix-in. We probably should use a mix-in. However, I'm not going to get into mix-ins right now, and I just want a quick kind of dirty solution. So all I'm going to do is I'm going to right-click this method, and what I'm going to do is I'm going to go copy/paste special, and I'm going to copy the AT entry. Now you may see it says no mappings found, in which case that means we can't actually go ahead and do that, which is unfortunate. And by the way, if you don't have that, then you need to go ahead and get the Minecraft development plugin for IntelliJ. So if you go Minecraft Development in the marketplace, you will find this one with 1.7 million downloads. That'll be the one. However, you see in this case it didn't work. Sometimes it just doesn't work. So in that case we need to use a great thing called Linkie. Here's good old Linkie. So in Linkie, what we can go ahead and do is we can make sure we're on mappings. First of all, this will be linked in the description, by the way. linkie.shadaniel.dev/mappings. Ignore the rest that's on here. It's going to come back, but we can get rid of it in a second. So you need to make sure it's on mappings, and the namespace will need to be set to yarn, since we're using yarn. Then we need to set the version to 1.21.1, and then we're going to say that we don't want a translation, and we do want to enable methods. We want to disable classes, and we're just going to type our method in here, and you'll see there are two methods which fit. So we need to find which one we're actually using. Now we're using the one that has a color. It seems, however, maybe that neither of these are the one we want. Let's go ahead and have a look at our method real quick. So we can see here this is the one we're trying to use, and that in fact this method doesn't want a color at the end as I thought it did. It in fact wants 4 floats, which saves us a little bit of effort. So what we can do then is we can just pass in the 4 floats. We can say float alpha, float red, float green, float blue. Then we can go back into our fluid widget, and we can actually, that saves us some time because we can actually just do that here. So that's perfectly fine. And then we just need to go ahead and obviously pass these in here. So we're going to use alpha, red, green, blue. And I'm just going to go ahead and actually copy these in like that. And it is once again still complaining, but we can possibly fix that in a second. So it does look to be, actually it looks that the alpha is the last float. Not that that's why it's erroring, of course, but we can quickly go ahead and fix that. So just adding in the alpha after the blue like that. Make sure you do that on all of them, of course, otherwise you might get some weird things happening. Okay, and then we can go ahead and find that one on Linkie. So that is going to be this one, and we can go ahead to the AW here. We can copy this. So I think you can just click on it to copy it, and I think that does that. So once we have gone ahead and copied our access widener, we can go into our source main resources, and we can create a new file, and we're going to call this our mod ID, so tutorial mod in this case, dot access widener. And then inside of here we need to type access widener v2 named, and then we can just copy the thing that we got from Linkie. So we can go ahead and give that a save. Now you see that for me I have some syntax highlighting and stuff. Once again, that is from the Minecraft development plugin, so if you want that then you need to go ahead and get that. Then we can go into our fabric.mod.json file, and inside of here we can come down to, I like to do this just above the mix-ins. I put access widener, and then we can put the name of our access widener, so tutorial mod.access widener. Then we need to go into our build.gradle file, and inside of the loom block just below mods we can do access widener path is equal file source main resources, and then we can do a $sign and then some brackets project.archives _base _name, which is basically our mod ID, dot access widener, like that. And if we go ahead and give that a reload, we should see during our build process our access widener now applies, which should also cause our build process to take a little bit longer. In fact, in this case it didn't, so I don't know if it worked or not. We can go ahead and have a look in the draw context class and see if it worked. So in this case it actually looks like we completely broke everything, which does happen sometimes. So let's make sure we go ahead and reload our project again, see if it fixes it. It looks like in this case it has not. So if you just right click your project and you reload from disk, you may see that it kind of fixes itself there. However, it looks like in this case it has gone ahead and made that method public. So let's see what the error is. So if we look in here, we have the texture, we have the x1, the x2, the y1, the y2. It looks like it then wants a z value, which is interesting. I was not aware of this. Let me just have a look at my existing code to see what's up with this z value, because I don't recall this being here in newer versions. It looks like in newer versions this z value is not in fact here. And if we look at where draw textured quad is used, you can actually see it is used here in draw texture. And this draw texture is used in a couple places, but the primary case that it's being used is here, where the z value is just being assigned to 0. So we can do the exact same thing. We can just assign that z value to 0, which should fix all of our errors that we have in here. Okay, so that has gone ahead and fixed that error for us. So now what we can do is we can go back into our fluid widget, and in the render method we can now go ahead and call screen utils.renderTiledSprite. We're going to pass in the context, the sprite. We're going to pass in this.x, this.y, and then on the y we're going to add this.height minus the fluid bar height. And the reason we need to do that is because we actually are drawing from top to bottom, not bottom to top. So we have to go ahead and basically start it at the top of where it's going to be. And basically that means that we have to add the height, which gets us to the top, and then we minus the fluid height, which gets us down to where the top of the fluid will be drawn. Then we want to go ahead and pass in the width, so this.width, and then the height, which is fluid height. And then we just need to pass in our colors. So we want to pass in red, green, blue, alpha. Now for the alpha, we're just going to put 1.0. And it looks like, in fact, in this case, we have it the wrong way around. Let's go back into our method and make sure that the float alpha is the last parameter. It's the same as in our render method down there. So that will go ahead and draw our fluid. Now we also do want to draw a tooltip as well. So we need to know if our mouse is actually going to be over this drawn area. And if it is, then we want to go ahead and draw our tooltip. So in order to do this, we're going to create a quick utility method that will just check if a position is within a box. So let's say private static boolean is point within bounds, and then in here we're going to pass in the int x, the int y, the int width, the int height, the int point x, and then the int point y. And all we need to do in here is a very simple bounding box check. So we're going to say return point x is greater than or equal to x, and point x is less than or equal to x plus width, and the point y is greater than or equal to y, and point y is less than or equal to y plus height. Basically saying we're further right than the left, and we're further left than the right, we're further up than the bottom, and we're further down than the top, so we're inside of it. Pretty simple bounding box check there. And then we can just use this method. So is point within bounds. We're going to use this.x, this.y, this.width, this.height, and then we're going to pass in the mouse x and then the mouse y. If the point is within the bounds, then all we want to do is we want to go ahead and draw the tooltip. So we're going to say draw tooltip. We need to pass in the context, the mouse x, and then the mouse y. Then we can just create a protected void draw tooltip. The reason it's protected is because maybe if we had a sub implementation of fluid widget, then we might want to override this method to do something else. So that's why we have this. So we can say draw context, and then we can say int mouse x, int mouse y. Now inside of here we're going to want to go ahead and get the fluid. So we're going to say fluid is equal this.fluidTank.variant.get fluid, long fluid amount is equal to this.fluidTank.get amount, long fluid capacity is equal to this.fluidTank.get capacity. Then we want to get the text renderer, so we're going to say text renderer is equal to the Minecraft client.get instance text renderer. Then we're going to say if fluid is not equal null and the fluid amount is greater than 0, then we're going to go ahead and get the text that we want to draw. Now it's up to you what text you can actually draw, but I'm going to first draw the fluid name and then I'm going to draw the actual amount over the capacity. So I'm going to create a list of text because there's two different lines that I want to draw there. So I'm going to say list of text, and I'm going to call this text is equal list dot of. The first one is going to be a translation key, so we can do text.translatable, which will pass in the fluid.getDefaultState.getBlockState.getBlock.getTranslation key. And then the next one will be text.literal. And this is going to be the fluid amount, and I like to represent this in millibuckets, which is like the Forge way of doing things. I don't really like how Fabric has this like 81,000 equaling a bucket. Like, I think that's completely stupid. So I like to convert this into millibuckets. So I'm going to create a method for this. So I'm going to do a private static int get millibuckets from a long amount. And I'll say, I guess, long millibuckets. And all we need to do is return amount over fluid constants dot buckets. And then we need to go ahead and times this number by 1000. And what I'm going to do is I'm just going to go ahead and convert this to a float and then turn this back into a long afterwards, like that. Then all I need to go ahead and do is say get millibuckets of the fluid amount plus slash, and actually I'm going to do this slightly differently. So I'm going to do %s space slash %s, and then I'm going to do space m capital B, and I'm going to do dot formatted, and that'll take in the fluid amount and then the fluid capacity, which will go ahead and just format that for me. Then all we need to do is actually draw the tooltip. So we can do context dot draw tooltip, which will take in the text renderer. It will take in the text, and then it will take in the mouse X and the mouse Y. And that is all of our drawing done. We actually do need to just call get millibuckets. I did completely forget about that. So let's just go ahead and pass that in like that for the amount and the capacity. Now the final thing I'm going to go ahead and do is I'm going to create a quick builder for this class just to save us a bunch of time in actually creating these widgets. So I'm going to create a public static class builder. I'm going to create a private final single fluid storage, which will be the fluid tank. Then I'm going to create a private supplier of block pos, which will be the pos supplier, and I like to just default that to a supplier of null. Then I want a private int xy and a private int width height, and then I'm going to go ahead and actually copy this in from my existing code, but you can write this out if you want. Basically just the builder methods to do this. So I have an x, a y, a position, a width, a height, and then a size, and then I have a bound which combines those. I have a pos supplier, and then I have the build method, which turns this into a fluid widget. As usual, the GitHub of this project will be in the description of this video, so if you want to go ahead and copy this builder class into your project, you can go ahead and do that. Okay, now that we have done all of that, all we need to do is go into our screen class, and in the init method, we can do add drawable, and inside of here we need to use our builder, so we can do new fluid widget dot builder. And if you want, you can actually create a static method to do this. I will in fact do that just to make this a little bit easier to use. So that would just be a public static fluid widget dot builder, and then this will just take in a single fluid storage, which will be the fluid storage, and then this will return a new builder of the fluid storage, just like that. Okay, and now we can just go ahead and actually say, instead of new fluid widget, we can just do fluid widget dot builder. We can go ahead and pass in our tank, so that will use this dot handler dot get block entity dot get fluid tank. Then we can do dot bounds, and we can pass in the positions. So if we go ahead and open paint.net, we can see here our screen. So if we just grab this inner top left position, so that will be 140 and 9. Then all we need to say in here is this.x plus 140, this.y plus 9. Then we need the width and the height. So once again, if we come back in here, let's select this entire black section, and I think we actually want this pixel on the end as well, even though it looks slightly weird. I don't remember how we created this texture, but clearly it's a little bit bugged. Either way, that is 25 by 70, so we can pass in 25 and 70. Then we can go ahead and provide the pos supplier, which will just be a supplier of this dot handler dot get block entity dot get pos. Then finally we can just do dot build. Now once all of that is done, we can go ahead and run the client, and when we get in the game, we should be able to see that our fluid is correctly rendered inside of our GUI. Alright, so the game has loaded. However, I just have noticed one minor mistake I accidentally made, and that is in the if y remainder is greater than 0 inside of our x remainder greater than 0. I accidentally put the sprite.get max u minus the min v, so we need to go ahead and make sure we change that to max v minus the min v, which makes me think it might also be broken up where that was used up here. We can just check. Yes, that is in fact broken there as well. So now we can go ahead, and now we fixed that, we can rerun the game, and it should hopefully work properly this time. Alright, so as you can see, we are now inside of the game. So if we open the fluid tank here, you can see that we now have a fluid drawn. So this is lava, as you can see, which is 10,000 over 10,000 millibuckets. So if we go ahead and look in like this one, for example, you can see that this is 1,000 over 10,000. If we look in this one, we have the water, and it's colored correctly. I know it looks really dark, but that's because our background, as you can see in here, is black. If it wasn't black, it wouldn't look so dark like this. But yeah, that's basically it for this tutorial. If you guys are curious where I got some of this code from, it is from my mod Industria. If you want to know more about that, I do streams of developing Industria quite frequently, so if you're interested in that mod, then you can check that out. That is a tech mod for Minecraft Fabric. And yeah, that's it for this tutorial. So obviously, if you guys enjoyed or found it useful, please do be sure to give it a like and subscribe. And yeah, in the next tutorial, we are going to be covering custom recipe types, so we can have custom machine processing and that kind of thing. And I will see you then. Goodbye.